This is a video about writing a little computer program using Python to approximate areas. We're going to first just walk through using the Jupyter Notebook how we've been doing and the approximation formula that we determined in class, just to use normal code, and then what we'll do is we'll modulate that code and put it into a little program that we can save and reuse over and over again to approximate the area. So to begin with, I'm just going to define a function, make sure to import my standard libraries, define the function. I'm going to define the left and right endpoint, the number of rectangles. So here we'll go from 0 to 3 with 6 rectangles, just so that we can check our work, because we know that the width of each rectangle should be a half. And so we will find the height of our first rectangle at 1/2 over, right? We should start at 0 and go over 1/2, and until the end of the endpoint, and sure, at the end of the interval, and sure enough, that's what our x values do. Now we're just going to find f of each of these values, and that will be these values y. And sure enough, remember our function was f of x equals x squared. Here we have each of these numbers squared. The areas of each of the rectangles is going to be the width, which was a half, times the height of each of them. So we'll say width times I for I and y, so then I'll take each of those and multiply it by the width, and we get our areas, and the total area is just what we get when we add all of these together. So 11.375. Now if we wanted to do this again and again and again, what we can do is just take the pieces, like the important pieces like the width, the x's, the y's, the areas, the total areas, and I'm going to write a function called area that takes the three things that we started with, the left, right endpoints, and the number of rectangles, and then just carries out those the steps that we walked through here, from determining the width, finding the x values, then evaluating the function at each of those x values, finding the area by multiplying each of those heights times the width, and adding them all together. Rather than just executing a cell called the total area, though, I added a little print function that will print a statement that says the approximation with the number of rectangles equals, and we're going to round the total area to 3 decimal places. So then if I wanted to use this function, I would just call area, left endpoint, right endpoint, and the number of rectangles. So if I wanted to try this to see that I get the same thing with 0, 3, and 6, sure enough, 11.375. The approximation with 6 rectangles is 11.375. So, okay, there's a little function that is just a result of kind of singular steps that we had made earlier. Also, what we can do is we can save this as a file. So, for example, I use a text editor called Sublime Text and wrote a very similar function, just added a couple of things, including a plot, to our earlier function, and I saved this file as integrator.py, that it's a Python file, in the same folder as this notebook. So if I look in the same folder as this notebook, I see this integrator.py file. So I can import that, the file containing this function, just like we do our other imports. So I'm going to import this and rename it the grader. So import integrator as the grader, and then when I want to use it, remember I called my function integrate. So now I'm just gonna, right, I changed the input to ask for the function, the left endpoint and the right endpoint, and I made n equal to a default value of like 1,000,000 or something, but we could change that to be 20. And after, whoop, that was actually very quick and nice. It didn't take too long because I only used 20 rectangles. But if I change this to a larger number of rectangles to get a more accurate approximation, something like 20,000, it'll probably, whoop, didn't even take that much longer. Wow. Maybe we could use a whole bunch of rectangles with this thing. Oh, too big. Yeah, this takes a little while. I think I had the default set to 1,000,000, um, and that's why it had been going slow. So with smaller n values, and 20,000 is not a small number of rectangles on the interval 0 to 2, but it was working pretty quickly. You see that it's still going for the big number here. Anyway, that's a function as a file. Enjoy.